All right, it's 5:30 on my clock at least. So I guess we'll make a start because I think I'm holding everyone from going to the pub. We probably all want to get there. So I'm Ian Kilpatrick. I work on the Blink team in Sydney. So I came here all the way from Australia. Weather's better in Sydney, but you know. Basically, we spun up a project in Sydney which is really just trying to explore the rendering pipeline and exposing that to developers. And we're calling this Glitter, by the way. So you can think of sort of like how you get pixels at the end of the day in your browser engine is that you tweak this, huge set of key value pairs. I think Nat said earlier it was over 400 key value pairs with some magical selector. This applies magically to some DOM nodes and you get your computer style out. You can sort of read that and prod that if you want to. Lots of magic happens and then you get pixels on the screen. We want to investigate sort of opening up all of this magic so that developers have far more power and far more sort of guarantees of performance so that they sort of don't drop off a performance cliff. So we think that the pipeline sort of looks like this. So, this is, fairly bog standard. So you've got your huge set of key value pairs up there, style resolution occurs, you get your computer style, and then you've got all of these phases that we potentially want to, at least think about opening up and exposing APIs to the developers. So that, a good example of why you might want to do this is that if you remember like 4 or 5 years ago when border radius wasn't a CSS property, for example, people had to hack the DOM essentially to put in images of the appropriate size just to get around to corners on their elements. Similarly today, with material design buttons, for example, you need to add a lot of DOM elements just to get that ripple effect from when you touch it to get that to render each frame. If this is really, really hard to support, why can't we just do it in a plain callback, for example? So another reason why we might want to do this is that it's very easy to fall off performance cliffs on the platform. So you've got 2 different vendors, lots and lots of these pipelines are huge, as you know. Lots and lots of magic happens in these pipelines. And it's very easy for you to, say, rely on a particular, Chrome's particular implementation of will change, for example. And then on Firefox, it works in a slightly different way and your app's non-performant, or vice versa. So in line with the Extensible Web Manifesto, we want to open these things up. The ideas I'm going to present next, they're incredibly rough. They're not set in stone at all. So we would love feedback on this and basically any ideas that you've got. So this is going to now turn into a sort of Q&A session of any ideas that you have for us to investigate. We've also started to discuss this in sort of the standards world. So we've got, do we have a task force yet, Shane? No, not yet, but soon, maybe, probably, yes. Yeah, so we'll have a task force that's sort of going to try and investigate a lot of these things. Yeah. So the first thing is style resolution and what we could potentially open up there. CSS is, sort of this magical language, very declarative. One thing in particular that we're interested in opening up is adding custom properties to CSS. Currently, if you want to say polyfill, flexbox, for example, as a canonical example, you basically had to pass this whole CSS style sheet, rip out the values, and then do some DOM mutations to polyfill flexbox. We think that's a little bit unmaintainable. So for example, here this just describes a color filter, which you can invert your color and then your text color will come out, an inverted color, for example. Extending CSS like that. We also think it's important to extend CSS in this way because it allows, we think of the computed property. Sorry, I'll go back a few slides. We think of the computed style object as sort of the data that you can pipe all the way through this pipeline. So any ideas on style resolution, anything that people would like to see, or any questions up until this point? Audience participation is encouraged. Mike. Yeah, so selectors is a hard problem. Not sure, maybe. Another, like an interesting thing that we could potentially do there is switch some selectors off. So say, you know what, I don't care about neighbor selectors. I really only care about class selectors or IDs. Let's turn a whole bunch of selectors off and implement my own nth child selector, for example. Yep.
What about the order of evaluation? For example, I mean, here you're accessing the color sort of the same property that you're evaluating. Like, what if you're registering two properties, kind of depending on each other?
Yeah, so we've put a little bit of thought into that. Basically, what we think we want here is either declared upfront, basically what you depend on. So say, to compute this color filter property, I need to depend on the color property and say the transform property for argument's sake. So then you can build up a DAG and then run through all of these little handlers when you need to. We also think that we can do this step here as a one-shot JavaScript fix-up at the end of style resolution, which is potentially nice. But yeah. Any other questions on this part? Yep. Ojan. Yeah. So what's our thoughts on that, Shane? Main style resolution. Yeah. Yeah. Oh, that's fine. Yeah. Yeah. So if you didn't catch that, basically, you inherit the non-computed value all the way down and then compute that value on each node effectively. So it's not as pretty as inheritance, but you still get the same effect. Does that make sense? Cool. Yeah, probably. Yep, potentially. Yep. Cool. Oh, sorry, yep.
So when you're constructing this DAG, say I had two things that modified the color property,
Mm-hmm.
ordered arbitrarily. Is there any way of establishing that?
Yeah, it'll essentially be where you registered it. So last wins. Yeah, arbitrary rule, but simple. Yep. Yep. This will be called after style resolution. So this isn't main thread JavaScript. So basically, we want to define, like either in a worker, for example. Basically, it's not main script. A lot of our thoughts rely on that. Basically, being it's not main script. It runs in a worker or in a pure function or something like that. If that makes sense. Yep. Yeah. Yeah, we don't want to sort of jump in and then you do a bunch of DOM manipulation in style handlers. That just wouldn't work. Yeah, well aware of that. Yeah, so basically, like if you think of it as, say, like an isolated function that it doesn't have any scope creep, for example. It will basically just have its inputs, and then it could produce an output, or modify some state on its input, and that's potentially it. Or for example, it's in a web worker in its own little isolated world, for example. Something like that. And a lot of our ideas sort of rely on this. You have a separate piece, computation engine that's not main script. Interesting thing that, things that you can start doing there is if you break up, currently a lot of, devs work is currently all on main script thread effectively, and it's this big bundle of mess. And engines like, React and things like that have tried to tease it out. Cool things that you can start doing there is like analysis on, okay, my paint stage, it's probably going to take like, 2 milliseconds, say. And then you can start time budgeting and FIPS locking based on that, for example. Potential idea. Yep.
If you want to add features to an existing CSS property, like let's say we support generated background images for like gradient stuff or things. If I wanted to add Sierpinski triangles, for instance,
yep.
Background image, that's an existing property, but I want to augment it. Is there a way I can do that in the system?
Not sure. Maybe. Again, these ideas are incredibly rough. Could potentially, define a new CSS function for that, or potentially, create a new property that just augments the old one. I think with that particular example, with Sierpinski triangles, you would want a custom paint callback, which mangles with the background canvas, for example. Cool. So sort of next sort of block down, we think that we want to expose, at the very least, a measure API for elements. Currently, it's very, very difficult to sort of tease out how your elements are going to lay out on a page. You sort of have to, push into the DOM, do a synchronous force layout with, calling client width or client height or whatever, do some mangling on the style and, potentially remeasure and things like that. And layouts internally have a lot of extra data available to them. So, they've got the potential aspect ratio of the element. They've got intrinsic widths and heights, max and min content contributions, as was described in the last talk, with text widths, for example. And so exposing a lot of this power, basically, I think this could be main thread with promises, for example. Could give a lot of power to the developers to at least start doing some more powerful custom layout things. I think someone was telling me the other day that CNN.com loads CNN in 2 hidden iframes or 3 hidden iframes just for measurement, element measurement, for example. So this is a pretty real problem on the web today, that you can't measure things and can't tease out this information. One additional example is that you can't pull out where your baselines are. So if you want to align 2 elements with baselines, there's no way to pull out that information. Yep. Yep. Yeah, so first and last baseline is if you've got a block of text, the first baseline is basically the base of the text on the first line. And then last baseline is that. So it's typical that you might want to align all of your last baselines. Like if you've got, say 3 paragraphs, you may want to align all of their first or last baselines. Yep. Yes, I didn't include it on the slide because I ran out of space. But yeah, it's something that we want to think about. Again, like this API is crap. It's more of just a conversation starter. What if we had this type of stuff? Yep, cool. Any other? Yep. Yeah, so basically this would cause potentially a measure at least on that fragment of the subtree, for example. But it wouldn't push layout further up in the tree. So you're right, yeah, we would have to potentially do layout. But we would return everything in a promise effectively. This is no different to calling client width or client height today. This just exposes more information in a more powerful way, if that makes sense. Yep, exactly. Like, you know, max content contribution, for example, should just be, oh, all of my text, sweet, it's that long. Whereas, you know, at the moment, people have to clone the div, make sure that style is the same, append it to a hidden iframe, 5,000 pixels, you know, off the main thing, work out how long it is, and then include that in their calculations. This is what, you know, Google Docs does today for their text measurement. Fun fact. It grabs it, sort of, this can also happen with, like, you know, potentially off, not in DOM tree nodes, where the element just gets its sizing info from a position in the DOM. So pretend you're at this, you know, second child on this particular element. What's your min content contribution going to be? And things like that. So again, rough ideas, but yeah. Anything else here? Thoughts, suggestions? No, sweet. The next one is sort of interesting and slightly scary. It's how do we start mangling with layout, for example, and give, you know, developers that sort of power. We've got some incredibly rough ideas here. We don't really know where this will end up because it's a very, very hard problem. So two very, very rough ideas. One, creating effectively a DSL, similar to how web audio works today, for example. You build up effectively a processing graph of all different types of operations you want to do on your audio stream, and then out pops a new audio stream, for example. So building it up in a, you know, declarative way, like this, for example, or with a pure function or some worker or something like that, getting a script to control boxes, which is incredibly scary as well, for obvious reasons. But exploring this at the moment, the benefits of having something like this is things like you could potentially perform optimizations based on, you know, how far you scroll down, for example. So it could potentially minimize layout costs for a very, very long list. You could potentially do things like implement new layouts in Java, like implement layouts currently in the engine in JavaScript to slim down the engine. So for example, you may want to rip out regions, for example, and put that inside of BlinkOn.js, for example, or things like, you know, table layout. Not saying that's a good idea, but it's a possibility. Another thing that you could potentially do here is start helping standards committees move quicker. For example, Flexbox, you know, it's taken, what, 3 or 4 years to get spec'd in a lot of browsers, and, you know, is just starting to see the light of day now. With an API like this, someone could hack it up over the course of 1 or 2 months, get it out there, and get far better feedback in the specs process to whether their API is correct and whether this is a good idea or not. So it's a very, very powerful but interesting concept that we want to sort of investigate a lot more. Sorry, any questions on sort of layouty stuff? No. Oh, yep, sorry. Mm-hmm.
How do we support the selection? For supporting selection, there is a program.
Mm-hmm.
It's a painful selection.
Mm-hmm.
And another is a traversing node
Mm-hmm.
for serializing the report as HTML.
Yep. Yeah, that's a good question. I'm not entirely sure how that would work. Yeah, sorry. Yeah. So one thing to note is, like, we've only really thought about box layout at this current stage. So just positioning boxes on the screen. And so I think you'd probably have to define, you know, how your boxes link to one another, given text selection. So a good example of this is, regions, for example, and just specifying the text flow, and then the engine could do that. We've got some rough ideas for like text layout as well. They're even, basically as far as we've got there is custom text layout would be cool. Yeah. So for example, like a potential, cool use case for custom text layout is a tech-based, an n-log-n or n-squared type text layout on the web, or implementing exclusions or regions. Exclusion, which is the path cutout things on top of this type of API. It could be interesting. Yep. Yeah. No, I totally agree. Breaking selection would be bad. Yep.
How do you avoid sort of a flashy experience, like basically get two layout classes, right? Like you're doing the BlinkOn.js regions implementation, right? You're gonna ask for a bunch of measures and things, and that's gonna have to cause some layout and some rendering probably.
Yeah, so but basically, because layout is sort of, you have a tree and then you need to pass a lot of information down the layout tree and then back up the tree. Both of these things need to run synchronous in line with layout, which is why this is a very, very scary idea. So with the DSL approach, it's relatively fine because we specify the DSL and it can all just be interpreted in C++. With the script, we'll need something very, very strong guarantees that you're not going to screw yourself. That's a valid point. Yep. Yep. Yeah, you're right. So I think with a lot of these APIs, because they're sort of running as fragments inside of the pipeline, would need very, very good tooling to show the developer, as you're working on it, hey, you're blowing your frame budget, you're taking like 10 milliseconds to do this layout, or you're blowing out your measurement or something like that. I think the answer to that is that we can't stop developers shooting themselves in the foot, but we can provide really, really good indications to them that they're about to. There's no way to stop a developer from implementing an n-squared layout like Flexbox, for example. Yep. Not sure. Maybe. Like it could be possible that. Yeah, not sure. Scared enough people? Great. Now for my personal favorite, painting. Basically, same again. Allow devs hooks into painting. So effectively, this is just a strawman. All of these code snippets are strawman, effectively. So you receive a canvas. You can do write operations only onto the canvas. So effectively, you can draw rectangles, draw images, things like that. You can't read any pixels out of the canvas. And this allows us to say, just record a whole bunch of paint commands and then insert them later into the global list of paint commands, for example. And again, this relies on, this is not main thread JavaScript. This is inside of work or inside of pure function or something like that. Any thoughts? Questions? Yep. No. Cool. How do I handle invalidations? Yeah. So there'll have to be an explicit, like, if you assume that the computed style is the object that you pass all the way through the pipeline, you'll say declaratively ahead of time, these particular styles will invalidate paint, or you have an invalidate call on main thread, for example, which says invalidate. What was that, sorry? Yep. Yeah. Yeah, I think you have to. It might be possible. It could be interesting just to invalidate a subregion, but I don't think that there's a strong case to do that. Maybe not. I might be wrong. Who knows? I'm very indecisive. And then there's a whole bunch of other stuff that we sort of don't understand yet. How does scrolling interact with all of this? For example, how does, do you want, there's lots of scrolling linked effects, like for example, on new Android Lollipop, the new over scroll behavior with the cool blubbery gray area. Yeah, do people know what I mean when I say the blubbery area? Good. Rick is nodding. Sweet. But you do this sort of stuff. How do we generate text fragment boxes, for example? We don't know. Yeah. So that's all I had prepared. Are there any other questions on this stuff? Or have I confused everyone? Sweet. All right. With that, I will let you all go to the pub. Thank you very much.